Hello friends, welcome back to aurabassociates. Today we will solve these 95 concrete frames which failed in design check. So at first I will unlock the model and I will go to the plan view of base. Here I will assign fixed support because in the last episode I forgot to assign fixed support here. So go to assign, join, restraint, fixed support, apply, OK. Now I will analyze the structure again for your satisfaction. Now go to design, concrete frame design, start design check. Go to design, concrete frame design, verify all members passed. This time you can say 94 concrete frames failed in design check. So this time I don't need to select them. Just go to the plan view and see them floor wise. For story 1 there is no problem, then go to story 2, there have some problem with this beam and also these 3 beam, okay, then there have some problem with the landing beam and also for these beams, okay. Next, for next floor problem is also same, then go to the upper floors. Here you can see this beam is overstressed. Okay. Now just unlock the model. Here make this one 3D view. Then go to define section property, frame section. We will change its torsional constant. So go to modify / show property. Go to property modifiers. Here make this one 0.001. As a result, this additional torsion will be carried out by the column. Click on OK. Click on OK. Click on OK. Now analyze the structure again. Now go to design, concrete frame design, start design check. Okay, go to design, concrete frame design, verify all members passed. This time you can see only 40 concrete frames failed in the design check. Here click no, then go to the plan view and see them floor wise to understand what is the change. This landing beam is still in fail condition. Here we have the same problem with these beams, but these beams has been solved. Okay. Okay. Now come back to the 3D view again. Unlock the model. Go to define section property, frame section. Here we are taking a copy of this property. So click on add copy of property. This time I will define a section with beam 12 by 24. So here this will be 12 inch and depth will be 24 inch, or you can change the unit also. Click on OK. Again take a copy of this property, add copy of property, and we will define beam 12 by 27. So here make this one 27 inch. Okay. Now click on OK. Okay. From here select all stories. Select this beam. We have to select this beam, this one. Okay. For all stories we have selected the beam. Then go to assign frame section property. Here assign this property, that means beam 12 by 24, apply. Now analyze the structure again. Okay, go to design, concrete frame design, start design check. Go to design, concrete frame design, verify all members passed. This time you can see 34 members failed in design check. Let us check them floor wise. Okay. Come back to 3D view. Unlock the model. I don't need to see the leveling and section of beams. So go to set display option. From here go to object assignment. Then uncheck this one. Click on apply. Okay. Then here click on show undeformed shape. Now here I have taken a decision that I will increase the length of this beam. Okay, I will extend this from here to here, and I will do the same thing for this beam and this beam also, because I don't need to increase the section anymore. Let us make it right. So we are at one story right now. Okay, so click this beam, then go to reshape object, select this beam and then extend this one up to this joint. Okay. Now we will do the same thing for this beam also, but at first let me check what is the loading value at this beam. This is 7.36 kilonewton per meter. Keep it in mind. Then delete this one. Okay. Now select this beam and go to replicate. From here select pick 2 points in model, then select the grid point of this column and then grid point of this column, then click on apply. Okay. Now check the loading value here. Right click of mouse, there is no loading value, so we will assign here some load. Go to assign, go to frame load, distributed. Then from here select wall load 7.36 kilonewton per meter. Go to apply and fine. Now we will extend this beam also, but there I have a null beam where we have assigned some wall load, and that is 6.77 kilonewton per meter. And for this beam there is no loading value. Okay, basically may have a wall. Okay, at this portion there also have a wall. Okay, so at first delete this one for all four. Okay, delete this one for all four. So select all stories and delete this one. Now select one story, then select this one, then go to reshape object, select this one again and extend this one up to this joint. Now for this beam and this beam, that means we will assign here this wall load value. Okay, this one will be as partition wall load. So select them, go to assign frame. Go to assign frame loads distributed. This time from here select PWL and maybe this value is around 6.77 kilonewton per meter. Apply. Click on show unreformed shape. Now go to the upper floors. From here select all stories. Then we can delete them. Okay. So delete them. Let me check. Okay. Fine. Now go to story 2. Select this beam and this beam. Okay. And replicate them at story 3, 4, 5, 6, 7, 8. Okay. Click on apply. Sorry, we don't need to select here all the stories. Ctrl Z or okay. Let me check the thing again. Okay. From here select one story. Select this beam and this beam. Now go to replicate story 3, 4, 5, 6, 7, 8. Okay. Click on apply. Okay. Now if we go to the next floor, we can see. Now go to story 8 because here at story 8, which is the roof floor, we don't need such big amount of load because there will be just a parapet wall. Okay. So what we can do, and maybe the parapet wall is up to this portion. Okay, up to this portion. At this portion we don't need this load. So here what we can do, we can divide this frame. Also for this one we can divide this frame. Divide them. Now here just select this one. Here just go to assign, go to frame loads, go to distributed. Just assign some wall load. Okay. Let us check what is the value. Okay, 5.88. Okay, we have to delete these loads also. Okay. Okay, fine. We will do them. Here just assign around 3.5 kilonewton per meter load. Apply. Okay. Here you can see we have assigned more loads than necessity. Okay. We will remove them because at this beam there will not be any wall load. Okay. So we will remove them. Select this one and this one again. Check. Here we will assign wall load, not partition wall load. So select them again. Go to assign. Go to assign frame loads distributed. Okay, 3.5. This time this is fine. Okay. Now we don't need to assign such a big amount of load at this portion. Also for this beam. Okay. So assign here 3.5. Fine. Now for these beams we don't need any load because there will not be any partition wall or any wall load. So click here. We can select them by previous selection. Apply here 0 kilonewton per meter. Apply. For this beam we can divide this one at joint. Now select this beam, go to assign frame loads distributed wall load 3.5 kilonewton per meter. Apply. For this one we don't need any load, so here select this one and 0 kilonewton per meter. Okay. Now for this beam, let us check either there is any load, that is partition wall load, which we don't need. As a result, select them and go to partition wall load and apply 0. For this beam, here you can see they have 6.27. Okay, so select them and also apply load 0 here. Okay, fine, but for the other floors, this is okay. Okay, for other floors, this is okay. Now, you can join this beam. You can join this beam by using this command. Okay. Now go to our basic work, that means we are working for failed members. Now let's go to analysis. Go to design, concrete frame design, start design check. Go to design, concrete frame design, verify all members first. Now, still 26 concrete frames failed in design check. See them floor wise. Plan view. We can start from story 2. Apply. Okay. Issue of this beam has been solved. Okay. Okay, you can see this time one column is overstressed. Okay. Now unlock the model. Select all stories. From here I will select this one and also this one. Then from here you can see the 3D view. Okay. From here you can see the 3D view. I will change the section of these two columns. So go to assign frame section property. Here I will assign 12 by 30. Apply. Okay. Let's check the structure again. That means analyze this again. Design, concrete frame design. Start design check. Go to design, concrete frame design, verify all members. This time 25 concrete fails. I hope failure issue of column has been solved. Let's start from story 2. Okay. Now I don't need to increase the section of beam anymore, and we are designing this structure for seismic design category C. So I will try to pass this beam by considering this one as SOWE intermediate. Okay, if you are designing your structure for seismic design category D, I will suggest you not to follow this procedure, but you are designing your structure for seismic design category B or C. In that case, you can try with this way. So right click of mouse, override SOWE special. Here I am considering this one as SOWE intermediate. Click on OK. Okay, but this problem is still not being solved. Okay, this issue is still not being solved. So we have no other option left. We have to increase its section. No way left. So right click of mouse, override again take it back to show a special. Now basically no option left. So what will I do? I will increase its section. We have a section that is 12 by 27. I will try with that one. So select this one, this beam, also this beam. Okay. But I had to select here all stories. Do this one again, or you could select previous selection. Now here just go to assign frame section property 12 by 27. Click on apply. Okay. Now analyze the structure again. Go to design, concrete frame design, start design check. Design, concrete frame design. Still number of field member is same. So go to the plan view of the story 2, apply, okay. I will give another try by considering this frame as over intermediate. Go to override, intermediate, okay. Still this problem. So consider this one as so special again. But let me check for this beam. Okay, this issue is being solved. So I will give a try. Let's make this one so special again. I will give a try by increasing the capacity of this two column. That means I will increase its section. Okay. So from here uncheck or unlock the model. Here I need to see the 3D view. Okay. From here select all stories. The size of this column is 15 by 35 most probably, or you can check. Sorry. (15 by 35). So I will change these two columns as per the section of this column. Okay. So go to assign frame section property. From here you can try with the lower section, but for this tutorial I am using 15 by 30. You can try with 12 by 30. Okay, here I am using 15 by 35 directly. Click on apply. Okay. Now analyze the structure again. Go to design, concrete frame design, start design check. Go to design, concrete frame design, verify all member passed, but still no solution. Go to the plan view, at story 2, apply, okay. Now we will give a try with show a intermediate again. So go to override. This time this issue is not being solved again, but for this beam, let me check. Okay, this beam is being solved. So at first solve this one. Override, show intermediate. Okay, we will do something different for this beam. So go to the upper floors. Let's make a try here. Override, intermediate. Okay, not being solved. Very fine. So give a try for this beam. Override this one. I am telling you again, if you are designing your structure for seismic design category D, you may not follow this procedure, but you are designing your structure for seismic design category B or C. In that case, you can follow this procedure. Okay. Okay. Now go to the upper floors. Overrides, intermediate. Okay, now go to design, concrete frame design, verify all members passed. You can see 13 concrete frame fails in design check. So unlock this model. At first, let me check its loading value, either there is any issues. Okay, this is fine. So basically no option left. We have to go to define section property, frame section, define another property by taking a copy from here, add copy of property. This time take this one as B15 by 27. Okay, so that means width will be 15 inches and width will be 27 inches. Okay, click on OK. Let me check the section again by changing the unit. 15 by 27, modify / show property. Okay. Now select here 3D view for this window. Here all stories, then change its property. From here go to assign frame section property B15 by 27, apply. We can change the property of landing beam also. Go to define section property, frame section LB 12 by 18. Now we can modify this or change this to 12 by 21. Okay, 12 by 21. So make this one 21. Okay. Okay. Now go for analysis. Go to design, concrete frame design, start, design check. Design, concrete frame design, verify all members first. 9 concrete frame fails in design check. So go to the plan view at story 2, click on apply, OK. This time again consider this one as survey intermediate and give a try. OK, this time this issue has been solved for this floor. OK, we already made this one as survey intermediate, so this issue also has been solved. Now give a try for this landing beam. You can consider this one as survey intermediate and let's check. Okay, but this issue is not being solved till now, so I will make this one again as survey special. Click on OK. Okay, let's solve this beam at first. Overwrite intermediate. Okay. Click on OK. Overwrites. Okay, this column is being failed at the top or story 8. Very nice. So we will change its property. From here, select all stories. All stories. You can see the 3D view here. Then go to assign frame section property. This time apply here 15 by 35 size column. Apply. Okay. You can see this column size has been changed. Now go to define section property, frame section, modify slash show property. From here make this one 15 by 21. Okay, click on OK. Click on OK. Now give another try. Go to run analysis. Go to design, concrete frame design, start design check. Go to design, concrete frame design, verify all members, passed. This time you can see all concrete frames passed in the design check. Now let me answer a question which may arise in your mind. See, this is a structure which is about, let me check the area. I will check the area approximately. Here area is total 2066 square feet, but we have only 10 columns, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, there is a lift core, but ultimately there have only 10 columns. Okay, as a result, this unexpected size of column and beam may come. If you need to provide common sizes of column beams, okay, in that case you can increase the number of column in your structure. As a result, such big size of beam and column may not come in your structure. Okay, but this totally depends on the architectural facilities. If architectural facility do not hamper, in that case you can increase the number of column. But if there is no option, in that case you have to go through this procedure. Okay, finally I will suggest you, if you consider any beam as a survey intermediate, though this is a structure which we are designing for seismic design category C, but I will suggest you to increase the size of this column with some extent. Okay, So let's unlock the model. Okay. Then define another property, that means go to define section property, frame section. Now I will take copy of this column. This is not very mandatory, but generally I follow this procedure, so I am sharing it with you. So go to add copy of property, then make this one around 38 inches. Okay, around 38 inches. So you can make this one as 40 inches, whatever you say. Then go to OK. See 15 by 40. As a result, you can say that this is crossing the limit of 2.5 ratio between L by B. Okay. 40, which is in crossing the ratio of 2.5. You can model a shear wall also, but I have separate tutorial for how to model shear wall. Here I am just showing you the structure or the basis of column. Okay. So here I am taking 15 by 40 inch column. Okay, you can solve this structure, that means solve this 3 column by using the shear wall also. Okay, fine. Here I am using just the column because I am just showing you the procedure. I am telling you again, I have separate tutorial for shear wall modeling. So I will not waste any more time here. So just click on OK. Now click all stories. From here select this column, and this column. Okay. Now go to assign frame section or frame, then section property. Now assign 15 by 40. Okay. Or you can change the dimension by 18 by 35 if there is no architectural hesitation. Let me check. Okay, there may have some hesitation if we increase the section to 18 inches. So we will increase this one to this side. But if as a result, okay, you can increase this column at back side. Okay, no issue. So 15 by 40 inches apply. Okay. Now finally save the structure. Check the joint again. From here select one story. Okay, all are fine. But again do this one. Okay. Now finally analyze the structure for the last time, hopefully. Okay, now go to design, concrete frame design, start design check. Okay, now go to design, concrete frame design, verify all members passed. So you can see all concrete frames passed in the design check. That's all for today. See you in the next tutorial. Thank you.